Section 4.8, we actually start getting into the other part of calculus, which is finding what's called antiderivatives. And if we look at the definition, a function f is an antiderivative of f on an interval if f prime of x equals f of x for all x's in the interval. What that means is you're going to go backwards. We've been finding derivatives. Now we're going to start with a derivative and say what would be the function that this derivative came from. Okay, so let's just kind of think about that. The process of recovering a function from a derivative is antidifferentiation. Okay, antidifferentiation. So if we had 2x, would it make sense that the function that would give us that would be x squared? So let's think about it. If you took the derivative, you'd go 2 in the front, you'd take 1 away from that, you'd get 2x. Okay? If the function were cosine x, what big function, if the derivative were cosine x, what function, if we took the derivative of it, would give us cosine x? That would be sine x. But now, let's think about this. X squared plus 1, x squared minus 8, x squared plus 100, etc. all have a derivative of 2x, right? Because when you take the derivative of a constant, that goes to 0. So we are going to write things in the most general way. If f is an antiderivative, then the most general antiderivative is f of x plus c, where c is an arbitrary constant. So if we were given 2x, then the integral, I haven't used that word yet, the antiderivative would be x squared plus c, sine x plus c, because there's a lot of things that would still have that as a derivative. Okay? All right, here's a part, and you actually have another sheet that has rules, but this one's great, and you could print this, but this is going to give you the rules for finding antiderivatives. All right? So when you have x to the n, all right, the rule says it's 1 over n plus 1 times x to the n plus 1. Let's see how that works, okay? If I have x cubed, okay, if I have x cubed, 1 over 3 plus 1, so that's what? 1/4 x to the 4th, all right? Now let's see if I take the derivative of this, do I get this? 4 times 1/4 is 1x to the 3rd. So that works. A lot of times we just think of it as this. Add 1 to that, divide by the same number. Okay, using that idea, if I have 2x to the 5th and I want to find the antiderivative, that's going to be 2x to the 6th over 6, which would be x to the 6th over 3. Okay, x to the 6th over 3. Now, if I take the derivative of that, am I going to get this? I would rewrite that as 1/3 x to the 6th. 6 times that is 2. X, take 1 away, 2x to the 5th. So it works. So you're going to add 1 here, you're going to divide by whatever that number ends up being. Okay? That's the big one. That's the one that you're going to use more times than not. If you have sine, say sine 3x, this says it's negative 1 over 3 cosine 3x plus c. So you're just going to use this chart to build yours. You're not going to necessarily remember all of that, but hopefully you'll get most of them. Important ones, e to the kx, 1 over k, e to the kx plus c. So if we had e to the 4x, we're going to have 1 over 4 e to the 4x plus c. That would be the antiderivative. All right, we're going to get enough practice in the homework problems for sure. Okay, so when we are doing this, you'll see them written like this. That's the integral of this thing. So this is the integral of f of x dx. Okay? That's telling you this is a derivative. We want to come up with the integral. So the integral of 2x dx is 2x squared over 2 plus c, which is x squared plus c. Let's look at this one. Integral of 1 over x plus 2e to the 2x dx. All right, if you look back at your chart up here that we had, the integral of 1 over x is ln x. So that piece is ln x. Now, plus e to the 2x. So we have 1 over 2, e to the 2x, and we had this 2 to start with. So that get multiplied there, plus c. So that ends up being ln x plus e to the 2x plus c. Here's the integral of this. We're going to do each piece. So this piece becomes x cubed over 3. This piece becomes negative 2x squared over 2. And this becomes 5x. When you have just a number, it goes up to an x. And then we have a plus c. We clean it up, and we might write it 1/3 x cubed minus x squared plus 5x plus c. Okay? All right, let's look at the problems. Whoop, maybe here. All right, let's look at number 1. Find an antiderivative for this function. So we've got f of x equals 13x to the 12th. So we would have 13x to the 13th, and we divide by that same number. Then you would reduce. You're going to get x to the 13th. And if c is 0, you don't have to put a c down here. So we're just going to put that as our answer. Okay? All right, we've got 3 of them here. Let's do negative 3x to the, I need a little bit more room than right there. So, a part, negative 3x to the, now when you add 1 to a negative 4, you get negative 4. I'm writing the same thing. You get negative 3 over negative 3. You're going to reduce that, and you get x to the negative 3 plus c. If you don't put the c on there, they're going to count it wrong. B part, we've got x to the negative 4. So we've got x to the negative 3 over negative 3. Okay? And I think in Math Lab, they probably are going to want you to write it like this. Okay? C part, we've got, let me write it, x to the negative 4 plus 3x squared plus 4. So this piece is going to become x to the negative 3 over negative 3 plus 3x cubed over 3 plus 4x. And when we clean it up, we're going to get negative 1/3 x to the negative 3 plus x cubed plus 4x plus c. Okay, number 3, find one for 29 over 2 square root of x to the 27th. I would say rewrite that first. 29 over 2, x to the 1/2, whoops, x to the 1/2 to the 27th, which is 29 over 2 x to the 27 over 2. Okay? Now when we take the integral of that, or the antiderivative of that, we get 29 over 2 x to the 27 halves plus 2 halves, because I'm going to add a whole 1 to that, and I'm going to divide by what that total is. So that's 29 halves. Okay? So now I've got, that's going to cancel, and I'm ultimately left with x to the 29 halves. look at 4. Find an antiderivative for each one when c is 0. So that means we're not going to have c in our answer, just like we did in the very last one. All right, the antiderivative of 1 over x. This is a rule. This is one of the rules, okay? And the answer is ln x. 6 over x is the same as 6 times 1 over x. So your antiderivative is going to be 6 ln x. And I just checked, and I don't think they're making you put that in absolute value or anything, so it might be fine to just put 6 ln x. Okay. All right, 3 minus 7 over x. Well, this is going to become 3x minus 7 ln x. Antiderivative of this one, okay? Remember the rule is 1 over k. Well, here's k. This is your k value. So we have negative 1 over 11 times this derivative, integral of that. If you look on your chart, it's cosine. It's negative cosine, I believe. Yeah, it's negative cosine. That's why I put the negative there. Cosine of 11x. So negative 1/11 times negative 11 just makes that a positive 1. So cosine 11x is your final answer. And C was 0. All right, now the integral of 20x plus 7 dx. So this piece is 20x squared over 2 plus 7x plus c. That becomes 10x squared plus 7x plus c. Okay? All right. Number 7, same idea. We're going to do this. I would rewrite it a little bit differently. Would rewrite it as the integral of 8t to the 7th plus 1/8t dt. Okay? So when we take the integral, we have 8t to the 8th over 8 plus 1/8. We'll do that on top. 1/8 t squared over 2 plus c. So reducing, we got t to the 8th plus 1/8 divided by 2 is the same as 1 over 16. So we've got t squared over 16 plus c. I think it will let you put it like that. If not, it might want 1/16 t squared. Number 8. All right, number 8. I would rewrite these with negative exponents like I've done right here. It's going to make it easier to be adding adding 1 to the exponent. So the integral would be x to the negative 4 over negative 4 minus x to the 6th over 6 minus, and this is 1/3, so that'll be 1/3 x plus c. So since this x is negative, it doesn't say we have to get rid of the negative exponents, but here's the thing. When you're given a problem with fractions like this, we rewrote it to start the problem. Let's put it back in fractions. So we would have negative 1 over 4x to the 4th, because that came to the bottom, minus x to the 6th over 6 minus x over 3 plus c. I think that will get you when you do the answer for that one. All right. Now, okay, for this one, let's write x to the negative 1/5, and we're going to add 5/5. I'm just going to show you what that equals. All right, and so that is 4/5. So we got x to the 4/5 over 4/5. Whenever you're dividing by a fraction, you want to flip it. So your final answer, 5/4 x to the 4/5 plus c. All right, let's do number 10. On this one, there's not a product rule or anything. It just becomes sometimes difficult to do integrals, and there are methods. But right here, this is pretty easy to go ahead and multiply. So you distribute 9x to 7 and to x to the 9th. And so that becomes 9x to the negative 8. Because remember, when you do x to the 1 times x to the negative 9, you add the exponents, and that's x to the negative 8. That's why that becomes that. Then we can do our integration. 63x squared over 2 minus 9x to the negative 7 over negative 7. Can't really reduce that, so the only thing is these two signs are going to cancel each other out. So we have 63x squared over 2 plus 9x to the negative 7 over 7 plus c. Number 11, really an easy one. The integral of that is negative 5 sine t plus c. Number 12, again, you're looking at your sheet, and the integral of secant squared is tan. So your answer here is going to be negative 11 tan x plus c. All right, number 13. Okay, we got some e things going on. So e to the 4x becomes 1 over 4 e to the 4x plus 9 e to the this, you got to think about this. All right, this guy here is like e to the negative 1x. So it's 1 over k, 1 over negative 1, so that just makes that 9 out front become a negative. That's what happened there. Negative 9 e to the negative x plus c. Okay, so from this, we had 1 over negative 1 times 9 e to the negative x, which just made that negative. Now, on this one, that looks a little crazy to do, and the easiest way to do it is to separate it into two pieces. 1/2, that's your 1 over 2, plus cosine 3t, let's make that 1/2, because there's a 1 there, okay? Then let's take the integral of that. So 1/2 goes to 1/2 t plus 1/2 times 1 over k. Remember, here is your k. So we have times 1 over 3. Integral of cosine is sine 3t plus c. So we have 1/2 t plus 1/6 sine 3t plus c. In math lab, I think I made a note that they write it as t over 2 plus sine 3t over 6 plus c. I don't know what happened there. This is a little bit more involved in this. Find the function satisfying dy dx is 4x minus 7 and y of 2 equals 0. So what they're saying is find the integral of this. Okay, so the integral of that is 4x squared over 2 minus 7x plus some c. All right, so that means y of x equals 2x squared, I'm just reducing, minus 7x plus c. Well, they told us y of 2 was 0. Y of 2 means you got to plug in 2. All right, y of 2 equals 2. I'm leaving some blanks here. All right, so when we plug in and figure out, well, y of 2 is 0 equals, this was squared. So 2 times 4 is 8 minus 14 plus c. So 0 equals negative 6 plus c. Add 6. So 6 is your c value. And so when we rewrite this, we have 2x squared minus 7x plus 6. That is the function that meets all these conditions. And we've got our last one, same idea, same idea. All right, this is the integral of 3x to the 8/9, and y of negative 1 is negative 7. So this becomes 3x to the, if I add 9/9 to that, that gives me 1/9, and I'm dividing by 1/9 plus c. So y of x is equal to 27x to the 1/9 plus c. I got the 27 because when you divide by this, you flip it and multiply. So it's 3 times 9. Okay? All right, then they gave me that y of negative 1 was equal to 7. And that means we're going to plug in. So we got 27x, 27 to the 1/9 plus c. And we're plugging in a negative 1 there. Okay. And so we're going to put a negative 7 here because that's what y of negative 1 was. 27. Negative 1 to the 1/9 is going to be negative 1. And so that's negative 27 plus c. Let's add 27 this side so we get 20 is equal to c. If we plug that back into here, we have 27x to the 1/9 plus 20 is our function. All right, that should get you completely going on 4-8.